Hello friends, I am Vijan Velivaril. All are welcome to my YouTube channel. In this third video on electrified area, we will see what is meant by this permit to work. Also, this neutral section, temporary neutral section, etc. And also some other points, important points regarding the electrified section. Okay. In our previous two videos on this electrified section, we have discussed ETR-1, ETR-2 and ETR-4. But we have skipped this ETR-3. ETR-3 is otherwise called permit to work. Permit to work. So ETR-3 is otherwise called permit to work. Where it will be used, how it will be used, we will see now. Here it is the diagram, rule diagram of station A. A part of it is only drawn here. See, here is an isolator, here is a section insulator, here also another section insulator, and we can see here another isolator. Let us take the power supply to this OHE is coming from this direction. From this direction it is coming. Here this is the upline and this is the downline. In the last video itself I have explained this. This denotes the elementary section. In this down direction you can see the elementary section is given even number. Here it is 22604, here it is 22606, and the next elementary section will be given 22608. So in this way even number will be given in the down direction. In the up direction you can see 22701, here it is 22703, and the next elementary section will be given number 22705. Here this is in the progressive number, it is given because the supply is coming from this direction. Substation is in this direction, from that direction only the power is coming. So it is numbered in the progressively. This I have already explained in the last video. However, I was not specific about this numbering. Down line always it is even number, and for up line always it is odd number. Now let us come to this ETR-3 permit to work. Suppose the PWI wants to work here with a crane, that is for unloading the sleepers or unloading the rail panel, etc. He will take a line block between station A and station B in the upline. So it is under line block the work is going on. There is a chance that when rain is used for unloading the sleepers or unloading the rail panel, there is a chance that the boom of the crane may touch the overhead line. So in such cases, the PWI must see that the crane and the staff is protected from this 25 kV line. It is already told that one must keep 2 meters away from the overhead line. It is the safe distance. If the boom of the crane is likely to reach within the 2 meters of this OHE, definitely the OHE should be shut down or power block should be obtained in this section to undertake the work. To safeguard the crane and also the workers, OHE power should be switched off. Here this elementary section is 22701. Now the section engineer PA will request OHE staff for blocking the power in this section or blocking the power in 22701 elementary section. Now OHE official will seek power block from TPC. At elementary section 22701, power block is required for engineering work. That information will be given by OHE staff to TPC. Now the TPC will inform section controller that he is going to take power block in elementary section 22701. This information TPC will be giving to section controller. That communication will be in ETR-1. Now the section controller on his part will contact the station master A and the station master B, and they will be informed that power block is going to be given in elementary section 22701. On getting this information, what the station master will do? We have already discussed all those things in the earlier videos. What are all the precautions to be taken? The power block cap or collar will be put on the starter and advance starter knobs. The points leading to the upline, those knobs will also be provided with the power block collar or power block cap. So all these precautions will be taken and the entry will be made in the power block register and also in the TSR in red ink. After taking all these precautions, station masters will communicate this to section controller. See, all these communications will be under exchange of private number that we have already seen earlier. Now, on getting this information from section controller what he will do? This section controller will inform TPC that all precautions have been taken. That information will be exchanged under ETR-1. That is TPC and section controller, the information will be exchanged under ETR-1. Then, so under ETR-2, TPC will inform OH staff that power block has been granted. On getting the information from TPC, OH staff will issue ETR-3 to the engineering official in charge of this work, maybe the SCPA. This ETR-3 is called permit to work. Though the power has been switched off, the line will also be earthed before handing over this ETR-3 to the engineering official. When the work is over, the engineering official will cancel the ETR-3 and hand it over to OH official. On getting this information that the work has been completed and got back this ETR-3 cancelled, the OH staff will contact the TPC then section controller will contact the station masters, cancel the power block and resume the normal working. Now let us take a case while working with the line block and also power block. The engineering staff is working here with the crane, and suppose it is found that the boom cannot move freely with the OH line above. In that case, the OH line is to be just shifted to a side. OH staff can do it only with the help of a tower car or a ladder trolley. They must require tower car or a ladder trolley. Now, the line block is in force, they cannot put tower car into this section. Here ladder trolley can be placed in this section with the consent of engineering official. The OH official need not inform station master. OH official can place ladder trolley in this section with the written consent from the SCPA. Then they can use this ladder trolley to shift this overhead line. Here it is the responsibility of the SCPA to see that ladder trolley is removed by OH staff before cancelling this line block. There will be several occasions in which more than one department have to undertake work in this section. Suppose let us take the engineering department and the TRD department together have to undertake some work in this section. In such cases, the block will be called integrated block. Integrated block. In the integrated block involving this TRD and also the engineering department, line block will be taken as well as the power block. Now, under line block, track machines will be sent into this section. You know, this the track machine block permit T-bar 465E. Using the memo, we can send track machines as a convoy into the section. Here, track machines will be sent into this section using T-bar 465E. The TRD department will require tower wagon also at the same time. So this tower wagon will also be included in this T-bar 465E memo. Track machines as well as tower wagon can also be included in this T-bar 465E while sending into this line blocked section. See the tower car, we are having 4-wheeler tower car and 8-wheeler tower cars. 4-wheeler tower car, normally the speed will be 40 kmph, whereas 8-wheeler tower car can go at a speed of 100 kmph. Previously we were having 4-wheeler wagons, CRT wagons. These CRT wagons were always causing problem for the railways. it used to derail at the points. Hence, the CRT wagons have been scrapped by the railways. Now we are having four-wheeler, these tower wagons. Four-wheeler tower wagon can go only at a speed of 40 kmph because the stability of the wagon will be very less. Whereas eight-wheeler tower wagon can go at a speed of 100 kmph. Now let us have a close look at section insulators. In this rule diagram, we can see these section insulators. Section insulator will be normally like this. Here there will be two runners going on either side, and these runners are metallic runners. It will conduct electricity. From the base of this runner, here the insulator will be provided. Normally ceramic insulators. From the end of this ceramic insulator, again line will be moving. Here, while the pantow is moving below this line, on reaching here, it will be touching the runner, hence the pantow will be getting power. As soon as reached here, it will shift it to, pantow will shift it to this line. Again, from this line it will get power. By providing this section insulator, what is achieved is this line is just given a break here. The power from this line comes only up to these runners. Here this power from this direction comes only up to this. Section insulators are necessary in the yard to separate elementary sections. Now let us see one advantage of electrified section. Suppose in a station, a train hauled by electric loco has passed the station with hot axle. One of the wheels developed hot axle, and the SM could not stop the train, and also other staff or gatekeeper, they could not stop the train. In that case, the TPC can be requested to stop the train, and the message can be given to TPC, and this message will be under exchange of PN. And the TPC has control over this OHE line, and by sitting in a remote place he can switch off the line. Switch off the line means the electric loco naturally will not get power and it will come to a stop. So in order to stop trains in such emergencies, the message can be given to the TPC under exchange of PN. Now let us see whether shunting can be done by an electric loco towards a line where power block has been given. So in a station, we are having an electric loco here. This loco is to be taken to this line. And at the same time, there is power block in this section. In this up line, power block is there. Elementary section 22701, power block has been given. Power block means here the section is dead from this isolator from towards this direction. Whereas this line will be having power. Now, can we undertake this shunting? That is, taking this electric loco to here and then to this road. Definitely we can do it, but there are two conditions for it. First, the loco pilot must be informed that he is going to be taken to upline where power block has been given, so he must not go far beyond this shunt signal. So that information should be given to the loco pilot. Further, a traffic staff should be sent here showing hand danger signal towards this direction. Towards the direction of this loco, hand danger signal should be shown by a traffic staff standing here, so that the loco will not be going beyond this area. Now let us come to the term neutral section. Neutral section is the section where feeds from two substations are connected by a non-conducting line. Here one substation here, another substation here, and the feeds from two substations are coming together here, and this connected by a neutral section. That means this section will not be having any power. It is a dead OHE. Why neutral section is created? The power from this substation is one phase, and here this substation is another phase. When these two phases are allowed to meet, means there will be heavy flash and everything will burn out. So in order to avoid this neutral section is created. Normally power from one substation will supply power to 40 to 50 kilometers. So here towards this direction 20 to 25 kilometers towards this direction. In the same way, in the other direction it will be supplying 20 to 25 kilometers. So altogether 40 to 50 kilometers one power station will be supplying power. Now here this line comes up to here. In the same way the line from here also comes up to here. And here the two lines are joined by a neutral section. Here this line comes here, then on either side there will be runners, and here in the center you can see it is a ceramic or porcelain non-conducting material is used, and these are connected by a line, and this line will be normally non-conducting material. When an electric loco is coming with the pantograph raised, the panto will touch the overhead line. Here it will touch the runner, then it will touch this non-conducting line, again it will touch the conducting runner, and here it will touch the overhead line and it will go. That is how the panto normally moves. Nowadays this non-conducting line is made of PTFE. PTFE means polytetrafluoroethylene. It is a material which will not conduct electricity. Actually this line, it will be having a core of glass fiber. It will be covered with the ceramic coating, and over that ceramic coating there will be PTFE. This PTFE neutral section will be normally 6.6 meter length. That is, from the end of this runner to this end of this runner, it will be 6.6 meters. Previously we were having conventional neutral section. Conventional neutral section will be having a length of 41 meters. Instead of this 6.6 meters, the conventional neutral section will be having 41 meters length. The problem with the conventional neutral section is, when a train is moving over this conventional neutral section, if the speed of the train is less than 30 kmph, what will happen? In the conventional neutral section, the loco, the panto will not be getting power at this neutral section. So it is lengthy neutral section means, if it is moving with a lesser than 30 kmph, there is every chance of getting this train stopped here. Thereafter, to remove this train, we have to send a diesel loco. In the case of chain pulling also the same will happen. If the chain is pulled in this neutral section which is having 41 meters length, the train will come and stop there. The engine cannot move further. A diesel loco is to be sent to hold the train forward. So this conventional neutral section is a problem in this case. Nowadays we are not having conventional neutral section, we are having this PTFE neutral section which is at present 6.6 meter length. Even we are having neutral section with a lesser length, 3 meter length PTFE neutral section is now available. Whenever a loco pilot with electric loco is approaching the neutral section, he must switch off the loco power. Otherwise what will happen? Up to here he will be having power, and on entering the neutral section the panto will not be getting power. It will go to 0 volt. So there will be a heavy flash and that will damage the panto. So in the neutral section, loco pilot must switch off the loco power. So in the neutral section, to warn the loco pilot that he is approaching a neutral section, a board like this will be placed first at 500 meters. Then a similar board at 250 meters will be placed, and on the last mast in rear of this neutral section, a board like this will be placed. That means he must switch off the loco power. Then on reaching here, after the neutral section, on the first mast there will be a board like this, which shows that he can switch on the power, that the neutral section is over, loco pilot can switch on the power. As I told earlier, which is a conventional neutral section, the speed of the train should not be less than 30 km/h. Here the problem will not be there, because if at all the train comes and stop in this neutral section, it is only 6.6 meter length. Suppose the back panto has stopped here because of loss of power, the front panto can be raised and the train can move further. So stopping of this train in this PTFE neutral section will not happen normally. In conventional neutral section areas, at times temporary neutral section will be created. Let us see how it is done, why it is done. In the neutral section, suppose in the track there happens to be some work, some track renewal or replacement of rail or rail crack or some problem with the track, where the speed of the train should be restricted to less than 30 km/h. There is every chance that the train will be getting stopped at the neutral section. So in order to avoid this, whenever there happens to be any work requiring speed restriction to less than 30 km/h within the 1 kilometer towards this side or 1 kilometer towards this side, that is from the neutral section 1 kilometer on either side, if there happens to be any work having this restriction of speed to less than 30 km/h, a temporary neutral section will be created away from this 1 kilometer. Suppose there happens to be some work here, that means beyond this 1 kilometer, a temporary neutral section will be created here, a temporary neutral section. Here this temporary neutral section, there will not be any OHE. Whereas here what they will do, they will connect these two lines with a jumper, so that when the train moves through here, it will get supply. Through supply will be there, but on reaching here, it will not be getting any supply. Not only that, here there will not be any non-conducting material. No OH will be there, no non-conducting material will be there, there will be only a gap. So on reaching here, the loco pilot must lower the panto. If the loco pilot does not lower the panto will suddenly move up in this gap and it will damage the panto. So wherever temporary neutral section is created, a board will be placed like this, which shows that the loco pilot must lower the panto. And after this temporary neutral section, such a board will be placed which shows that now loco pilot can raise the panto. So the lower and raise the panto, such boards will be placed at a temporary neutral section, because there will not be any overhead OHE or even dead line. The location for creating a neutral section is selected in such a way that the area is plain and there is no gradient at this area. Also, there should not be any LC gate. Further, there should not be any stop signal, that is, the location should not be near the home signal of the station. So all these points are taken into consideration while creating a neutral section. Now with this third video on electrified area, I think I have covered almost all important points concerned with this electrification. Go to the 3 videos now you are having on this electrified section, and raise your doubts in the comment box. We will discuss it. Okay, we will meet in our next video. Okay.